will be recorded, and then I will share the link again. Okay, just in case you want to revise back. So hopefully everything will back to normal, so we can have the physical class. Because online class, I'm not sure about at your side whether you okay with online class or not. But personally, I would prefer to have physical class, because physical class I can see all your facial expression, all the stuff like. Okay, it's much more interaction, much more participation. Instead of doing this one, just talking to the screen, not my style. Okay, now I'm now again, any question, please let me know in the chat. Okay, don't be what, just try your best to participate, right? Okay, question 20. Yeah, before that, any question you want to ask for the MCQ? We have 差不多50题在这里。OK， 哪一题是要问不明白的？Give me a second here. I'm fixing my pen. Yeah, the pen 卡着。Give me 1 minute. Okay, ready. Okay, if no question, then first look at question 20. Just quickly go through this one. Maybe some of you finished this one, maybe some of you didn't do this one. So just look at question 20. Now, 看题目. The figure 21 shows a ball with weight W. So basically you're given a diagram like this, where there's a string attached to the ball, okay, and then you have this one, the weight, and another unknown forces pulling it. So whenever you have a string, label it tension. Okay, again, remember I said when you label tension, the arrow needs to be pointing away from the object. 就是你指出去，给你的 object 是这个圆圈吗？你 label tension 的时候，你的 arrow 是指出去啊。Okay, pointing away from the object. That's how you label tension. Now at the angle here, so the question asks, the tension of the string is ABCD. Which one? Okay, so first you have to know that this system is in equilibrium. So all the forces are in equilibrium, meaning that we can plot the force diagram. Let's plot the force diagram. So treat the object as a point. Here you have the point. So you take the vector summation of it, meaning that you have 3 forces here, 1, 2, 3. So you take the direction. So start from here. Maybe I put F first. F pointing to the left, this is F. Okay, F, and then I plus the tension. So from here, I continue the head to nose. Okay, tension here, and then final is weight. So combine here. So you'll see that this force diagram, when you add up together, right, they will come back to the original position, the initial position, the point. Okay, and then you label the angle here. This is the data. This is 90° here, and then find T, the tension of the spring. So express T in terms of F and W. So how do we find T? So this one you use the cosine formula. Cos theta equals to cha, right? Cha. So where is the A? Adjacent is this one, and hypotenuse is this one. So you focus on this angle here, because when you cos this angle, then this angle is your angle of reference for the A and H. So this would be opposite. Okay, so this one equals to W divided by T equals to cos theta. So T equals to W divided by cos theta, and this is your answer for tension. So you can actually calculate the actual value of it given the weight and the angle of the system. Question 23. Look at question 23. So we're going to spend 10 more minutes and then we move on. Okay. Question 23. Now, the diagram shows an object of mass 2 kg suspended by two strings from point X and Y. Okay, X, Y. 2 kg of object suspended by two strings. The tension in each of the string is, so calculate the tension. First, label the tension. Here you have T, this T1, T, right? One string attached to the object, you label pointing out of the object, T, and then you see the spring, right? The string separated into two. Okay, so you label one T here and one T here. And the first T, this one being the total tension, okay, and then it separates out. Okay, so we forget about the total tension. We do the 1 and 2 because we know that if you plus these two tension together, it becomes the same one, the total tension. Okay, let's work individually. Now, angle given here is 40. 40 here, 40 here. First thing you have to know, again, the system is in equilibrium, meaning the forces are balanced. Forces are balanced. Let's draw the force diagram. Draw the force diagram, okay? Now, point form, again, this is your object. What are the forces acting on the object here? You have to label all of the forces. Okay, so first thing is, of course, the mg, weight, W equals to mg. Okay, and then you have tension, so label the tension here, 1 and 2 here. Okay, now the angle here is 40 and here is 40. Tension, tension is given, right? 40. Now I want to find, since the two tension is diagonal, it's inclined forces, right? So I can resolve it into vertical and horizontal forces. Meaning that now I want to resolve the tension into vertical and horizontal. How do I do that? Focus on this T. Let's look at this T first. If I take T cos 40, then it becomes the horizontal force. Okay, so this one horizontal is T cos 40. Remember I said when you cos the angle, meaning that you're pulling it down. Okay, you're pulling it down. So T cos 40 is the horizontal, and the vertical here is t, the opposite, sine 40. T sine 40 would be the vertical. Now this is just the left side. The right side also same. So you have 2 t sine 40. Okay, now for objects that are in equilibrium, we learn about that sum of vertical or horizontal forces are 0. Sum of vertical horizontal forces are 0. Okay, you can write as this summation of Fy equals to 0, or you can write summation of Fx equals to 0. So this one simply means that the sum of vertical forces all are 0. Okay, if you add them up together, you will get 0 for a equilibrium system. Now for this one, since you have weight given here, let's take the vertical forces, because now we want to find T, right? So vertical forces, so I write the sum of Fy equals to 0. So what are the vertical forces? You have this this one over here, T, T, and W. Other than that, we don't look at them. Okay, so first thing, pointing up is positive, pointing down is negative. So you have T sine 40 plus T sine 40, and then minus W. Okay, and then equals to 0. So you're taking the sum of them equals to 0. So now you bring the W over there. So it becomes, this one I guess add up 2t sine 40 equals to positive W. So from this equation, you know that the vertical force acting upward is equal to the vertical force acting downward. Okay? Or if you 如果你觉得好像很麻烦，是一直要写这个 sum of vertical horizontal forces, then you can straight away start from here. Okay, I write this out just to let you see. Okay, you can straight away go from here. Straight away you take upward force equals to downward force. Yes, no problem. You can start with from here. Okay, so this is the more formal way to do it the more form standard way to do it. Now 2t sine 40 equals to W. Then no problem you can find T already Okay, how do you find T? W equals to mg, right? So W is mg. So m is 2 kg, g is 10, so it's 20. 20 divided by 2 sine 40. So T equals to 20 divided by 2 sine 40. Then that is your answer, which is 15.6 Newton. So each tension is 15.6. That is how you use the equilibrium of forces to calculate individual forces. Okay. Question, what else? Question. Let's do the last one, question 38. Question 38, you're given a diagram again. So an object of 0.5 kg mass is pulled by a force at an angle of 60 degrees from the horizontal. So if the object encounters a friction of 5 Newton, what is the value of F? 0.5 kg. So the force is slanted at a 60 degree. And if it encounters a frictional force, so acting on this one here, is F equals to 5N. So now first, let's find where is the direction of motion. The direction of motion is the green arrow. It is moving to the right, okay? So moving to the right, friction should be acting to the left. Now, first thing is that you have to resolve the force down to the horizontal force. Okay, because now the frictional force and the applied force is not acting in the same direction. One is slanted, one is horizontal. So you take force cos 60, then it becomes the horizontal force. Okay, of course, when you cos 60, right, it becomes horizontal, right? This one, the magnitude, the magnitude is of course less than the F here, because it shows that it is only a portion of it. Okay, 它只是它的很像一个 portion 罢了。So meaning that F cos 60 must be less than F 啦。Okay, now you cos this one down here, and the vertical forces same. This one is F sine 60. But now we don't care about the vertical forces, because vertical forces, right? It is 90 degree to the horizontal line. Thus, it has no effect on the horizontal forces. Okay, perpendicular forces doesn't have effect on each other. Okay, so we only focus on the horizontal now. F equals to ma. You learn about this one. This one simply means the resultant force, the net force, will cause the object to accelerate, right? So the resultant force in this system, what is the resultant force? In this system, it is the F cos 60 minus 5n. Okay? Because F cos 60 must be bigger. Why? Because the direction of motion is acting to the right. So F cos 60 must be bigger. So you take the bigger minus the smaller one. That is the resultant force. Okay, equals to 0.5 over the acceleration. We don't know, right? We don't know the acceleration. Okay, now next, okay, what do we want to find here? What is the value of F? What is the value of F? Okay, first thing that you have to know, is there any acceleration here? Yeah, let me see this one first. Pulled by force. What is the value? Okay, now acceleration is not given here, meaning that you cannot calculate. Okay, because you have two unknown, one is A and one is F here. So what you do is that, because you know that the resultant force is acting to the right, I write down here, acting to the right. So F cos 60 must be bigger than 5. Okay, it must be bigger than the frictional force, only then it can move to the right. So F cos 60 bigger than 5. So F is bigger than 10. You will see my answer sheet from my solution there. I write down this one, F bigger than 10. Okay, because cos 60, you move over there, you will get 10. F is bigger than 10. So it has, meaning that this equation means that the force must be bigger than 10 in order for the object to move to the right. Otherwise, if it's less than 10, meaning that it won't move because of the frictional force. Okay, because of the frictional force, it won't move. Okay， 如果你不信，你试下，如果 F 是等于5啦，5是少过这嘛，5，然后你拿 F cos 60，5 cos 60， you will get a smaller value than 5, meaning that it is smaller than the frictional force, thus the object will not move. But since in this condition, it says that the object moves to the right, okay, so F has to be bigger than 10, and the only possible answer is D, 14 Newton. Okay, 因为 A, B, C is 2, 5, and 7, then all of them out. Okay, so just now I talked about this one, F equals to ma. We don't need this one because acceleration is not given. Okay, just now I thought the acceleration is given here. So acceleration is not given, then you cannot use this one. Okay, now let's continue to today's lecture. Now, today I'm going to talk about only two sections. Okay, still we are at the equilibrium of forces. Now, pay attention for this one. This is very important, this one. Popular questions here, okay? Now, we are going to look at elevator physics. Okay, now, let's imagine you are in an elevator where the elevator is initially at rest. Okay, it's not moving. Now, label all the forces acting on you right now. The forces that are acting on you, first, it must be your weight, W equals to mg, right? W equals to mg. And then Newton's third law. What does Newton's third law says? Newton's third law says that every action will create a reaction. Okay, but what does it mean? Every action will create a reaction. Take a moment and think about it. Okay, meaning that for every force, it will create an opposite force of the same magnitude. Okay, think about previously the lesson we learned about impulsive force, right? So you have a ball moving to the wall, okay, and then when it hits in contact, it will exert an impulsive force to the wall, and at the same time, the wall also will exert an impulsive force on the ball. This is an example, shows that the Newton's third law of motion. It says that every action, there is an opposite reaction. Okay, so when you act force on the wall, it will also act a counter force on the object. So same with this one on the lift. People, if you're standing on the lift, okay, since you're in contact with the surface of the floor, the lift floor, okay, meaning that your weight will act on the floor, and then the floor also will act on you. And this is what we call it again. This is the reaction. Okay, for every surface, there is a reaction. Now, since these two are balanced, since this is in equilibrium at rest, so we can write that R equals to W and R equals to mg. Two forces are balanced. Okay, now this is the first case. Second case, if the lift is moving, same here, if the lift is moving with constant velocity, okay, let's say moving up with constant velocity. Now label your force diagram, same, it doesn't change. W equals to mg and then R. Okay, but this one, it is moving upward with a constant velocity, meaning that for constant velocity, acceleration is zero, right? Constant velocity, acceleration is zero. So if you take the formula F equals to ma, since acceleration equals to zero, then your net force also equals to zero. Okay, net force equals to zero. If the net force equals to zero, meaning that you will also get R equals to mg. R equals to your own weight. Okay, because there's no net force, man. No net force means R and mg are balanced. Okay, number three, case number three, this one. Case number three, and if you are standing here, and then I said the elevator is moving up with acceleration. It is accelerating upward. Now, W equals to mg. R. Now you have acceleration, and acceleration is moving up. Okay, now listen here. Acceleration moving up, if there is acceleration moving up, meaning that there is a net force acting up. I label net F net also acting upward. Okay, the F net is always the same direction as the acceleration one. Acceleration acting up, F net acting up. So if there is a net force acting up, meaning that this one, the reaction force must be bigger than your weight. Okay, it must be bigger than your weight so that it moves up, right? It moves up. So R must be bigger than mg. And if I want to label what is the F net, I will take the R minus the mg. This is the resultant force, right? R minus mg. So from the equation of motion, F equals to ma, where F is F net, you substitute this one inside. This one you put inside here. So you will get what? R equals R minus mg equals to ma. Okay, clear? So R minus mg equals to ma. So I can express in terms of R. So R equals to ma plus mg. And this is how we derive this equation here. R equals to ma plus mg. Later I'll show you what does this mean. Okay, now the fourth case, if the lift is moving down with acceleration, you standing here, so your force acting down, W equals to mg, and R here. Now acceleration is pointing down right now. Okay, acceleration pointing down, so F net, where is F net, is acting downward. So if F net is acting downward, meaning that W, my weight, must be bigger than my reaction. Okay, so F net equals to, I take the bigger minus the smaller one, W minus R. Okay, so from the equation F equals to ma, substitute W equals to R, W minus R inside. So you have W minus R equals to ma, and then your reaction equals to this one, W, you put mg lah. I put it here, mg. Okay, ma minus mg. So mg minus ma, and this is the reaction. Okay, now we now have worked out the equation of motions for this four scenario. Only focus on the box one, R equals to how many, R equals to how many. Okay, now notice that for lift that accelerate upward, case number three, the R is equals to ma plus mg. Mg is my weight, right? My weight. So my weight plus ma, meaning that R is bigger. Okay, R should be bigger. R is a bigger value than your actual weight. Okay, that is why when you stand inside a lift, when it moves up, right, you will feel you are heavier. Right? Sometimes you feel that, right? You feel that your weight, you feel your weight is greater because the support force is greater now. The R is greater, the support force. Okay, so the support force must apply excess over the gravity force to accelerate you upward. And same with the case 4. Case 4 is moving down with acceleration, right? So sometimes when you stand inside a lift, right, it moves down, you feel like you are weightless. Right? 你感觉到你比较轻. Why? Because the R is small. You see here the R is mg minus ma, so it has to be smaller than your weight. Which is why you sometimes feel weightless, and which is why during a free fall, you also feel weightless because there is no the support force. Actually, the sensation of weight, right? The sensation that we feel, right, that comes from the support force, comes from the surface. If there's no surface, there's no support force, and then you don't feel it. Okay, 我讲的 support force 就是那个 R 啦 ，R reaction. Now remember all this form. Okay, now if I were to put a weighing machine, 如果放一个量体重的 挤在这边，在这个 lift 里面，如果这个 four case 呢，它是站在一个体重什么量那个 weighing machine 的 weight balance。Okay, so the reading on the weight balance. Listen here, the reading on the weight balance is the R, not the mg, not the weight. Okay, I repeat, the reading on the weight balance is the R, not the weight. Meaning that 如果那个 question 问你take example for case 4， 如果有一个人站在 lift， 然后那个 lift accelerate downward， 然后那个 question asks what is the reading on the weight balance? Then you have to calculate the R, not the weight. You have to calculate the R. So you take this equation here. R equals to mg minus ma. That is the reading shown on the weighing machine. Okay, so to the bottom line is if you stand on the weighing machine and the lift moves upward, the weighing machine you will get a greater value for the weighing machine. And if it moves down, then the weighing machine you will get a smaller value than your actual weight. Clear? Okay. Now, I here 只剩下1分钟多, so let you just quickly take a screenshot of this one if you want to take a screenshot just as a reference or your own note, okay, because we are going to lose this one. Now, let's rejoin, log out and log back in, and then we'll continue further. Okay.